200 years ago, when the economist Pareto came up with the optimality theory. And it was very simple that if you have too many objective functions in the economy, you cannot create a solution where you make one better off without making the other worse off. So optimality is about getting to that situation where you cannot make one objective function better off without making the other function worse off. So that's where the whole concept of optimality came. Think about an economy. An economy like India, which is growing at 8%. This is one objective function, but you have other objective functions as well. For example, you need to question whether this growth is inclusive or not. So while you are growing, you also need to see whether that growth is embracing all the sections of the population. So this is as far as an economy is concerned. Think about a company, and you'll find examples like you need to deliver certain things in terms of the customer fulfillment processes. And on the other hand, you've got to deal with costs. And I think the first in the field of business that this problem of optimality was taken up was in the year 1929, when Harold Hotelling, the Stanford mathematician, brought in this concept of his puzzle that he framed was very simple. That you have an ice cream vendor in a beach, and you want another ice cream vendor to also participate in the process of selling ice cream in that beach. Where would you think the second ice cream vendor need to place itself? And this is an optimization problem which was solved through linear programming. And he found out that for competing commodities which are very similar to each other, it was through the program of minimizing the transportation cost that you could actually achieve the best optimum. Much later on, in the year 1982, that it was Michael Porter who brought in the concept of competitive advantage. And he brought in the concept that if you have two objective functions, for example, if you have differentiation as an objective function, and you have cost leadership as the other function, then the best way to optimize would be to be on the productivity frontier. So look at this productivity frontier that I've drawn, and if you consider any of the points on that frontier, it is a unique point where for that point, the differentiation that you achieve will be the best in terms of the cost leadership that you have. Any other point which is not on that productivity frontier will have a situation which is not optimal. So that's how you get to the situation in a business case where you have two different objective functions which you're trying to optimize, and you do that through the productivity frontier. So I move on to the search for optima in business cases. And I think businesses are very different, and you obviously have businesses which are far less complex. For example, you can take the simplest business that I can think of, making of salt, for example. It's a very simple process, one single SKU, you don't have too many SKUs to think about. But you have, on the other hand, very, very complex businesses. For example, automotive. We have had some examples of automotive and what kind of supply chain you could have in that. Or think of an automotive supply chain, for example. Very complex. And you have the problem, and we face this problem in Europe, that you have BMW, for example, having one single automotive line in Munich, making maybe, let's say, 13 different models from one single line, and you have 700 variants possible to be there from one single line. So you have so many piece parts to be organized, and all to be reaching there on time to be able to deliver. And so therefore, this is a kind of a very complex nature of puzzles that we're dealing with. So whether it is simple or whether it is complex, you ultimately have to answer the very simple question that if you have any starting point in your business, and there is a demand on that starting point, and there is a supply on that starting point, what you need to do in an S&OP process is meet supply and demand. That's very simple. That's the very simplest part of the puzzle. But if your nature of business is complex, this meeting of demand with supply would have far deeper implications as you go along trying to solve that. And I will take you through some of these examples where we try to solve this puzzle in various facets. I start off by talking about the demand side of the issue a little bit. And think of the e-commerce businesses. Think of, let's say, an e-commerce business where you are putting something on the cart, a virtual cart, and your action on putting something on that virtual cart will create a cascade of events in the entire supply chain. And if you want the delivery to be faster, the entire pressure on the system, the demand on the supply chain would be even more. So this is one example of creation of a certain demand. Let me take another example, also taking from the fashion space. Zara, for example, was trying to put up a store, and it wants to change its designs, let's say, every 20 days or every 15 days. What kind of a supply chain demand planning you would need to be able to cater to that? Demand planning is becoming very, very different sort of ball game going forward. I mean, we have already seen that happening in the case of e-commerce. We've seen that happening in the fashion industry, and especially in the case of fashion industry, where you are not replacing what has been sold. For the very high-end fashion, what gets sold from the store may not be replaced. So it is not with replacement. So it's a boutique kind of a store. So you have different sort of models of demand. On the supply, on the other side, you have various constraints. Think about the shop floor which will produce that product. How do you ensure that that particular production is going to happen just when it is required? It is not going to be early, and it is not going to be late. So this is the basic problem of any supply and demand planning, that you got to produce things which are needed, and you got to produce them exactly at the time when it is needed. And to be able to do that, the decision that you need to take has got to be at the latest possible moment. Because if you take a decision which is too early to produce something, you will be clogging your pipeline with that product. And therefore, when it is actually needed, what is actually needed will not get produced and will be delayed. So this is a very, very important planning puzzle, that when do you actually initiate the production process? Any production process, the decision to initiate that process is the most vital decision. Because once you have taken that decision, you cannot retract. And therefore, you have already created a pipeline of production which will get produced. It's not in your hand. So we have two parts of the puzzle as we see over here. One is the demand side and the other on the supply side. And you have an ecosystem. That's what the fourth box is talking about. It's an ecosystem where you are dealing with lots of other challenges in the environment, which is about competition. You are taking decision in a space where others are also taking decisions. So you got to see and you got to be sort of influenced by those decisions, or you need to influence the decisions of others as well. So that's the ecosystem where you are in. There are a few other puzzles also which are happening in the background. And the first one is, of course, the puzzle of bullwhip effects. When your supply chain is too large, these effects will be very, very compounded, because you have different parts of the chain taking different decisions. And maybe a very small change in demand could create a very large change in supply. And that's what the bullwhip effects are all about. Because if your entire chain is not integrated, you will not see the puzzle all in one, let's say, integrated form. Because you will be trying to solve puzzles in your own small corners. For example, solving a puzzle of a production run in a particular schedule in a production run. You're trying to solve a puzzle which will be limited to the knowledge and information that you have in that particular area. But think about the entire chain. Let me give an example of such a large chain, which starts, in the case of aluminium, from bauxite mining. And you produce alumina from that. From alumina, you produce aluminium. From aluminium, you produce all kinds of downstream products, which could be, for example, right up to beverage cans. So you start with bauxite, and it could well be that you're bringing that bauxite from Australia to the United States, producing alumina out of that, and you could be exporting that alumina to somewhere in Brazil to do smelting and producing a beverage can which is exported to Middle East. So this is the kind of a chain that you have. What kind of information systems do you think you need to be able to service a demand at the right possible moment? So this is the kind of a supply chain puzzle that we are sort of talking about. So we're talking about multiple objective functions, because at the end, you've got supplies or customer fulfillment processes to be dealt with, and on the other, each and every decision will involve cost. So therefore, whether it is terms of cash flow or whether it terms of inventory, you've got to deal with that as well. So that's the kind of puzzle that you have to deal with. Any S&OP process, and I'm talking of S&OP process by design, not by chance, has to deal with preparation. And I think the major strength of such a process is that it gives a one single instant view of the entire process at that point of time. It is not what a local planner is thinking at a certain part of the chain. If he's thinking of a certain part of a chain, he will also know in a process which is well designed what is happening in other parts of the chain at that point of time. It obviously is dealing with assessment of finite capacities. And it has got to deal with also things which incorporate information all at one single instant. And finally, it has got to have a decision support system. So these are the basic strengths of any S&OP process that we can think of. On the other hand, there are some opportunities, because every time a decision is taken through an S&OP process, the consequence also will be tracked. The consequence will be known. It is not like taking a decision, an ad hoc decision, and that not knowing what the consequence would be. And finally, you can do what ifs. So that's the other great opportunity that you have, that you can do what ifs. Scenario analysis will be possible, and that's a great opportunity to have. On the other hand, every process has its weaknesses, and a very well-designed S&OP process would also have to deal with a very strict disciplining which is required in terms of data. And I think one of the major learnings of mine, having implemented such a process in Europe, is that there was enormous amount of discipline in the German system, which allowed us to sort of implement such a system, such a complex system, in such a short span of time. So therefore, enormous amount of discipline is required. And there are no quick fixes. There's got to be the pains that we have to go through and set the process right in terms of the actual data that is required to be collected from the various process centers. And it cannot satisfy all the stakeholders. Ultimately, every S&OP process has got sales on one hand, operations on the other, and sales and operations planning, to my mind, has got to be something which is independent of sales and operations. And that's the way you can deal with these different stakeholders and the demands of the different stakeholders. So you cannot have quick fixes. You cannot satisfy all the stakeholders. These are certain weaknesses. And on the other hand, of course, the threat is that in a changing world, the algorithms are changing very fast. And so therefore, continuous upgradation, of course, remains to be something which we have to deal with. So the case study, in short, what I'd like to talk about is that Novelis Europe, which is part of Hindalco, is a 3 billion euro company which had plants in 6 countries, 13 plants in 6 countries. And it had a sort of a product mix which had 3 very specific streams. One was the automotive stream, catering to the end users like Audi, Daimler, BMW, Jaguar. So these kind of customers were there. The second product that it did was the beverage cans, which was supplied to the can makers like Rexona and Ball. And thirdly, it also catered to a large number of small customers who were in the foil business. So this was the kind of product mix that we had. And of course, Novelis is a global leader in recycling. and also in the rolling. It's in fact the global leader in aluminum rolling business. So this is the company that I'm going to talk about. And as we started this journey, we had three very basic objective functions. The first one, of course, was that we had to improve the delivery performance. And when we say improving the delivery performance, it means that each and every order, in fact, Europe did not have anything like the concept of make to stock. Everything is finally made to order. So when you have everything made to order, it meant that every order which got entered into the system had a delivery date which was communicated to the customer, and you had to actually meet that. So it was rather a very difficult puzzle with so many SKUs, especially in the automotive. The second objective function was that all the products that we were making went through one single bottleneck resource, which was the Alunorf hot mill. So you have the second very difficult function that you have to deal with is that having invested in such an asset and being the bottleneck, you obviously had to improve the throughput through that bottleneck resource. So this was a very important objective function that also had to be met. And thirdly, we had to optimize the stock turns. So when we started this journey in 2008, we had stock turns in the level of 4. That means you were carrying 3 months worth of inventory in your entire chain, starting from very primary metal or scrap in that form to the final product, which could be in different stocking points. And you also had intermediate stocking points and intermediate WIP. So overall, the entire inventory of the system was very high. So this was the sort of driving force for us to also see that we reduce the inventory. And if the inventory was high and it was having a high delivery performance, it probably meant something. But in this case, we had a high inventory, but a low delivery performance. So of course, it meant that the production process had to be looked into, and the entire customer fulfillment process had to be worked on. So these three were the major objective functions, and what appeared was that the most important piece in this whole process was missing, and that was the company planner. So when you look at the tools that Europe was using, you had macro planner, which is the basic tool for doing the long-range scenario planning. So you start with your budget for the year, and you break it down into quarters, you break it down into months, then you know which customers to service. That's part of your macro planner. And the output of that macro planner is finally, it gives you the monthly production plan, and it also predicts what kind of inventory you would end up with and what kind of buying that you need to do in terms of your inputs. So this was the basic sort of structure of the macro planner. And what you also had in Europe was the scheduler. That means what exactly you need to do in the shift. Let's say you take a particular finishing line, and what exactly that finishing line would do in the shift was properly optimized through a scheduler. So you had the basic foundation of the macro planner, and you also had schedulers, which were scheduling the mills and the different finishing lines. What you did not have, what we did not have, was the company planner. And company planner works in the domain where an order is entered, and it has got to have a scheduled to ship date on one hand. So one of the outputs of a company planner is to sort of create a schedule for an order. That means once you put an order into the system, when do you expect that order to be produced? So this is the first part of the journey. The second part of the journey in the company planner is to find out through an iterative process when you need to start the production run so that you're able to deliver that particular order to the customer on the date which you have sort of predicted. So it's a back and forth operation which is done through the iterative process, done through certain things which I'll talk about in the next slide, where you are able to sort of balance these two things together. And the other issue was that Europe was working through a very, very constraint-based system because you had the Alunorf hot mill, which was a major constraint.
And there were a few other constraints also in the finishing lines. For example, the coating lines or the annealers, the heat treatment lines. These were also other smaller constraints in the finishing area. So you have the hot mill, which is a constraint. You have a lot of other equipments which are also bottlenecks in the system. So therefore, with several number of bottlenecks in the system, to be able to predict an order when it will get sort of scheduled or having a scheduled to ship date for that order, and finally also ensuring they're able to actually produce that order on time was the missing piece which was provided by the company planner. It was a big project, and in those days, a €5 million project wasn't a small project in Europe. But we took up this challenge, and we were confident that we had the wherewithal in Europe to be able to deliver that. And we exactly took 1 year. So from the start date of the project to the end date of the project when we went live, it took exactly 1 year. So it was a very, very good project that we could do in Europe. So when I talk about execution in any project, I think we started off with a baseline. So that means you start off with where you are. And we started off with the current value, which was about 4.5 stock turns. And we had a delivery performance to these automotive customers, which was far less than 70%. So that was the starting point. And what we wanted to achieve, which was a future value, was about 6.5 stock turns. So you improve your ability to sort of churn over your stocks, and which of course would mean that you have less inventory in hand in terms of the amount of volume that you're delivering. So you have less inventory in your hand. And we also targeted a delivery performance improvement of 20% as sort of an initial output. And if you look at the steps that we took, I think the first step, which was very important, was on the demand management area. And that is what we found out was the sales quota allocation process itself. So you have, let's say, different value streams. You have a can or a beverage can value stream, or you have a automotive value stream, or you have a specialties value stream. The entire value stream will have a different approach in terms of the sales guy pulling in the orders and putting them in the system. And unless you have a very good sales quota allocation process, how would you process those orders when it all goes to one single bottleneck? So a very strong sales quota allocation process with very rigid rules was our first step in the journey. And of course, through the netting algorithms and the mapping of the entire process, we were able to match demand with supply at each and every stocking point in the process. The next issue that we had to sort of grapple was the concept of the nightly run. That means when you sort of want to optimize things, you need to stop somewhere. And that stopping of the entire calculation and everything, I mean, it started off 12 midnight. So when 12 midnight, you take all the information in the system and you do a nightly run, and early morning, you find out that which are the orders which need to be having certain start dates of production. And then you give that as a sort of a decision support system to the planning guys, that they have the choice of starting that production activity based on the output of the nightly run. So it was a very good way of sort of doing this. And that is what we said was generation of the flexi orders, which could be converted into works orders once the planner had agreed to do so. I need to talk a little bit about the organization. And this is very important because ultimately people will deliver what we would want them to do with the tools. And we had to change the vertical nature of organization, which was plant-driven. That means a Göttingen plant manager was delivering output with certain key result areas. Instead of that, we shifted it to a value stream-based organization where it was a particular product and its value stream, which was going through different plants right up to the customer. So the head of that value stream may be having his product being produced from different units. So the unit manager was not responsible for delivering the final value. So it was the value stream head, who was head of automotive, who was coming from sales. He was made responsible for delivering the final product to the customer. So this is the way we shifted from a very vertical approach to a horizontal approach, which went across the entire value stream. So in terms of sourcing of inputs to the final delivery of the customer, the product was moving through different production processes, through different units. The responsibility was given to the value stream leader to be able to finally deliver to the customer, because that meant that he had to also look at the sales quota allocation. He also had to look at the sourcing of the inputs, so he was taking responsibility for the inventory in the pipeline as well. And finally, of course, we had to create hierarchies. For example, a certain sales quota allocation could go wrong because there could be less orders in certain value streams. So what do you do in that scenario? So you create a hierarchy of products, and you say that if this product, the sales quota allocation is lower, then the next product in the hierarchy will obviously get that allocation. So you create a very rule-based system, and finally we were able to match the end-to-end supply chain problems. Of course, we had to put in the KPIs in place, because that's a very important element as well. Because there are going to be planners, there are going to be production people, there are going to be sales guys, and to sort of bring them all together, you need the KPIs to be put in place, because that's where collaboration becomes very important. And you can only do that once you start measuring and monitoring the different KPIs. There are a few things I would like to sort of, at the end, sort of summarize, is that there are three things which were very important. The first one, of course, was the business rules. And unless this sort of implementation at the very outset does not set what are going to be the business rules for the S&OP process, I think it will be very difficult to sort of go forward, because things will be very confusing, and it will be not possible for a particular value stream leader to be able to agree to certain things whenever it came to certain conflicts appearing when we were sharing the same bottleneck resource. And once the rules were made, it was very important that we sort of followed the rules. And this is a very important part of the, let's say, the supply chain and S&OP planning process to be successful. And I'm reminded of some of the examples where we found that you have the S&OP leader who is not part of, let's say, production, who is not part of the sales team, and who is working at the center. So let's say you have a center which is based out of Zurich, and you have units in different countries spread out across Europe. So therefore, I'm reminded of this great book by Mintzberg, Structure in Fives, where he's talking of that you have the center and you have the operating team. The operating teams could be working in different units in the planning function. And then you also have to look at the autonomy of the sales guys who are working in the fields, and the autonomy of the units as well, because the units also have certain roles. They also have got their assets, and they also have to see the capacity utilization of their assets. So a very complex puzzle. How do you create collaboration in such a complex network of things? And I think here, setting the business rules and creating the collaboration across the supply chain through the KPIs are two very, very important things which sort of facilitate the process of the S&OP to be successful. And of course, we've talked about a lot of data in the morning. The data accuracy becomes very important, because you could have hundreds of machines with different processing times and different quality issues involved. So if your data is not right in the system, whether it is a local ERP or maybe it's an SAP system, if your data is not correct, then you'll probably get outputs which is not going to be helpful for you. And I think here, all these plants of Göttingen, Nachterstedt, or Allenhof had a very, very good, very disciplined way of capturing data. And we found out that we should use the modes instead of the average data, because that sort of gave you the right. Through experimentation, we came about that, and that is the way we sort of captured the data, and then it really helped us. So validation of data, extraction of data and really doing a very good prototype testing, this was some of the key elements that helped us to succeed. In sum, I would like to leave you with some of the points for future deliberation, is that in days to come, I think volatility is going to rise. Whether it is in terms of demand, whether it is in terms of cash flows, is going to be rather far more volatile than we can think of. I don't think we have created good products which has reduced volatility. Even in financialization, we have seen that happening, that we have lots of products which are supposed to reduce volatility, but it finally has increased volatility. I think in manufacturing as well, we'll have to deal with this issue of a very volatile sort of environment and a very high level of constraint-based system. Removing constraints from the system will become even more difficult going forward. So volatility in a constraint-based system is going to go up. Assumptions, very difficult. It is going to be that we'll have to deal with assumptions which will go wrong. And as I gave that example of the timing, how quickly, how in an agile manner we are able to deal with these sort of changes in demand or in terms of supply or in terms of products. I recently came across a case where a particular e-commerce firm had set up a factory for producing certain items in India. And within 6 months, that factory simply did not have a single order. So therefore, you create an asset to service a certain market, and you find that in 6 months' time, that product is completely vanished from the scene. So there's something else which is probably selling more. So we have to deal with this, and the assumptions, therefore, need to be, we need to quickly estimate and change ourselves. Supply is always going to be more than demand. Let me leave you with this thought, that meeting supply or making supply exactly meet demand will be very, very difficult. Supply is always going to be more than demand. And this is, therefore, a typical challenge for most of the e-commerce players. Well, at the end of the day, they will have to return capital. They cannot play a valuation game forever. And therefore, this is going to be very important that the optimization process needs to factor in ways of dealing with this challenge where supply is always more than demand. And third is that how do we make the algorithms sort of factor in the latest information? Because the latest information, as we think what it was, for example, in our case, it was maybe 8 hours. We took a snapshot at the midnight, and we thought that is the way to do it. Going forward, I don't think we can think that you can take a snapshot midnight every day, and that's the way to deal with a particular problem or a puzzle. So this is an area where the algorithms also have to be sort of taking very faster snapshot of things. But at the end of the day, I think we have to make our puzzles simpler. And S&OP process, to my mind, has got to look at how to make the puzzles look very simple. The reason why many of the corporates, and especially I see that happening in India, is that the people who are running the show, the leaders, they do not see the value, is because we do not make matters simple for them to understand. And I think the S&OP process, the entire designing of this process and what we can sort of benefit from that process needs to be presented in a way which appears rather simple. Otherwise, we'll get lost in a maze of things and we'll not be able to convince the senior management the real sort of benefits that can come out of it. So these were some thoughts, and I'm exactly on time, not a second less, not a second more. Thank you.